labs folder in Blackboard and find the Freefall lab. The goal is to measure the acceleration of gravity for Raleigh. To do that, you'll basically use what was V is V naught minus GT, a linear equation. V naught minus GT becomes V is V naught plus GT. Likewise, the quadratic equation, y is V naught T minus 1/2 GT squared, becomes y is V naught T plus 1/2 GT squared instead of minus, making down the positive direction. The accepted value for Raleigh is 9.79 meters per second. What you're going to do is you're going to use the Loggerlite software to gather the data, and then reading on the back of the lab sheet, it tells you how to transfer that data into Excel. You're going to use that data to graph the three equations, two we talked about before, plus acceleration versus time. And you're going to analyze the coefficients to estimate the acceleration of gravity for Raleigh. The first equation we've already talked about. That's the final velocity not known equation graph. You will want to crop out the part of that graph that is parabolic and get rid of the data that after it hits the floor start bouncing around. You want to get rid of that. So you will not fit a straight line to this. You will fit a second degree polynomial. Show the equation on the graph. Click that option to show r squared on the graph. And basically you're looking for the coefficient of the t squared term or x squared term to be about 4.9, because double that is 9.80 meters. The second equation we also talked about, that is linear. You should see a linear graph, again crop for the free fall portion. Get your linear equation, and the slope is your estimate of the acceleration of gravity for Raleigh. The third, which is not usually all that great, you can try it, is the acceleration is a constant. That equates to a horizontal line. The slope is 0, so you need a linear trend line, and you should have about a 0 slope, and the vertical axis intercept is your estimate of acceleration of gravity for Raleigh. Now, your best graph should be the final velocity not known, or y as a function of time. That's because the Go Motion device, Sonic Ranger, it knows when it sent the pulse, it knows when it gets it back, it knows the speed of sound, it can calculate the position. But to get the velocity time graph, the average velocity is the change in position over the change in time. This means it takes two data points of time and position to generate one data point for velocity and position. So this data is not quite as good, but it's usually generally pretty good. But to get the acceleration data, you have average accelerations, change in velocity over change in time. So this takes two data points from the velocity time data to make one data point for the acceleration. So it's rougher still. And for that reason, this might not be all that great, but go ahead and give it a try. So when you transfer the Loggerlite data into Excel, the time in seconds will be in the first column. Y, or the position, will be in the second column, velocity, meters per second, third column, acceleration of gravity, meters per second, fourth column. So you will select the first column to be the independent variable, horizontal axis for your y versus time graph, and then the second column will be the output. To generate the velocity time graph, the time column is not adjacent to or contiguous with the velocity column. So you will block off the time column, press the control key in Excel, and then block off the data column and generate this graph. Likewise, for the acceleration time graph, you'll block off the time column, press the control key, and block that off and generate this graph. Methods of estimating the acceleration of gravity for Raleigh. The experimental value, first of all, that will be, you'll take half the coefficient of the quadratic term, second degree term, and double that. That's your estimate of acceleration of gravity for Raleigh. 97 meters per second. So absolute value, experimental minus accepted value over accepted value times 100 to make it a percent. And then do the same for the velocity time graph where the experimental value for G is the slope. And maybe, if it's worthwhile, do that for the acceleration time graph. If you get less than 5%, that's considered excellent. 5 to 10%.